Hello friends, continuing with chapter of units and measurements. Today we start with the second part of this chapter, that is the measurements of length, mass and time. Today we take up measurement of length. Next time we'll take up measurement of mass, and after that we will take up measurements of time. So how we carry out measurement of length? Let us try to understand. Length can be measured by direct methods as well as indirect methods. Length can be measured by direct methods and indirect methods. First we try to understand about direct methods. In direct methods, instruments are used to measure lengths. In direct methods, instruments are used to measure lengths. For example, look at the table. Look at the table. This table reveals that meter scale is used to measure length minimum up to 10 raised to power minus 3 meter, that is 1 millimeter. Now vernier calipers is another instrument which is used to measure the lengths up to minimum up to 10 raised to power minus 4 meter, that is 0.1 meter. Now screw gauge is another instrument, that is micrometer or screw gauge is another instrument which is used to measure minimum length up to 10 raised to power minus 5 meter, that is 0.001 millimeter. Now microscope is another instrument which is used to measure lengths up to 10 raised to power minus 6 meters. And electron microscope is another instrument which is used to measure lengths up to 10 raised to power minus 10 meters. That is, we can view atoms with the help of electron microscopes, because the size of an atom is of the order of 10 raised to power minus 10 meter. For all other distances beyond these ranges, indirect methods are used. Scientific principles or mathematical principles such as echo principle and parallax principle are used to measure distances. So number one, we take up echo method. The principle of echo method: waves undergo reflection from the objects on which these are incident. I repeat, waves undergo reflection from the objects on which these are incident. Now what is the method? A wave of velocity v known is sent to the object and its echo is received back. Time delay, that is time taken for forward and return journey, t is recorded. Now this is the object, star is the object, and this is the wave which is probe wave, we call it as probe wave of velocity v, and this is the echo which is received back on its return journey. Okay. Now time delay t is recorded. Now the distance of the star, if x is the distance of the star, then x will be equal to v into t by 2. Why t by 2? Because it is the double time taken for the wave in going to the star and coming back to the sending end. So thus time is twice here, so we have to take half of it using the formula S is equal to ut, the basic principle. So distance here is x, which is equal to v into t by 2. V in place of u, t by 2 in place of t. S is equal to ut. You are familiar with this formula. Using this formula we can calculate distance x of the star from the source point of generating wave. Okay. Now distance of the object is x equal to vt by 2. Now uses of echo method. Echo method is used, number 1, to measure distances of heavenly bodies, and for this lasers are used. Number 2, it is used to measure thickness, oblique flaws in sheet structures, and ultrasonics are used for it. Now assignment 2.2. Question number 1. A laser is a source of very intense monochromatic and unidirectional beam of light. These properties can be exploited to measure long distances of heavenly bodies. Therefore, a laser light beamed at moon takes 2.56 seconds to return after reflection at the moon's surface. How much is the radius of lunar orbit around Earth? And the answer would be 3.84 into 10 raised to power 8 meters. Now question number 2. A sonar uses ultrasonic waves to detect and locate objects underwater. In a submarine equipped with sonar, the time delay between generation of probe wave and the reception of echo after reflection from enemy submarine is found to be 77.0 seconds. Calculate distance of enemy submarine. Given speed of sound in water is 1450 meter per second, and the answer would be 5.5825 into 10 raised to power 4 meters. Okay, and you solve these two numerical problems on the basis of the text that you have learned, and thank you so much.